deals with this to take the best energy from the modules. What we call it? What is there in the inverter that deals with this variation in the voltage and ampere of solar modules to take the best energy from them?
MPPT.
Yeah, that's true. Okay. Can you install two different modules to same inverter?
We have many MPPTs.
Yeah. It's good. Okay. Can you consider more DC energy or PV energy to the inverter higher than the inverter capacity? Such an example, if you have a 20 kilowatt inverter, can you install more than a 20 kilowatt of solar capacity?
Yes, we do. Yes, we can.
On which base?
حسب قدرة الجهاز نفسه هو في أجهزة بتكون مثلا
because there will be losses anyway due to, I mean, could be different things, but I think already like due to the angle, cloud coverage potentially, and then other system losses, I think.
Yeah, the answer is yes, but it depends on the inverter itself. Usually it's mentioned in the inverter data sheet, like what is the max it accepts in terms of PV capacity. Also, it is something we discover while we simulate the system. If you guys remember the simulation session done by Michelle, also the software also tells you what is the maximum you can install with the inverter based on the current weather and the weather variations expected in the future of the system, especially that when we design a system we consider 20 to 25 years for the system. Yeah, so it is yes, but it depends. Anyone remembers that type of inverters that we talked about last week?
SMA inverter.
Oh,
No, not the brand. Actually, we don't focus on the brands. Yes, we showed some brands, just a model, for example, but I don't mean brands. I mean inverter types.
I think
On
you
a grid,
mean
off a
on a
grid.
grid, off a grid, hybrid. I think that.
Yes. And what is the most recommended one for Gaza if you have an option to choose out
For
of these
grid.
types of inverters?
Hybrid inverter.
Yes.
Hybrid.
Yes.
Hybrid inverter.
You know what is the reason why we recommend this for Gaza situation? Why we recommend hybrid?
I think we have a lot of several problems inside Gaza, like power planet, like load management. We haven't got a stable and continuous electricity.
Mhm.
So we need to use the hybrid generators, like that.
Any more ideas about it? What you said is correct, but there is also more reasons. Any other reasons for recommending to use hybrid inverters in Gaza? Yeah, I can tell you like because hybrid inverters can act and operate as an off-grid systems with batteries, can operate with diesel generators, also can feed into the grid in the future. Like it is somehow a function that is there in on-grid inverters, but hybrid inverters can do so, or most of hybrid inverters have this option. So considering hybrid inverter in the current systems as an off-grid systems can be switched to on-grid in the future to feed into the grid. Yeah. Yeah. So I have also another question about the DC cable connectors. What we call them? I'm talking about PV side.
MC4.
Can you replace them by direct connection, the standard one we use for AC?
Please repeat your question.
Can you replace MC4 connectors with the standard basic connectors that is used for AC cables?
No.
Yeah. I like this no, direct. Yes, it is no. This is big no, and Caroline will talk about this today. What is the yield? Stan talked about it, and Michelle showed it to you guys during the simulation and design session. So what is yield?
I think yearly production.
Yeah, what is it?
The kilowatt,
Production is part of the answer. Yeah.
the production per annual, I think. Production of kilowatt per annual.
Mm-hmm. How you call it? Like
It's
yes.
it's a kilowatt hour per kilowatt per peak.
Yes. Yeah,
Yes.
that's true, and I see also Raed just
That's right.
typed it. Yes, yes, it is the annual kilowatt hour energy you get from kilowatt peak of a solar system, and usually this number you get by simulation. I have the last question here. What is the STC?
So the standard conditions.
Do you remember the numbers? What are they?
1,000 standard kilowatt watt hour, 1,000 per meter square.
Okay.
At the
It's,
STC conditions, at the specific temperature, specific radiations, and others.
Excuse me, about the solar radiation is 1,000, cell temperature 25 degrees centigrade, the air mass it's 1.5 am. I think that.
Mhm. And when we say 25 degrees Celsius, here we talk, do we mean the ambient temperature or the frame temperature of solar module,
The
or
cell.
what we mean?
The cell,
Cell
the cell temperature.
The cells.
Yes.
The cells.
Yeah. Yeah, that's true. So that means we are ready for the session of today. Before Caroline start, anyone has any question about the first 3 sessions?
Excuse me, I'm asking in last sessions about the shielded photovoltaic panels. لماذا عفوا باللغة العربية ليش ما بنستخدم الألواح القابلة للطي مثلا في الريهاوسنج أو في الريبيلد في قطاع غزة؟
There is no specific answer for this, like why don't you use them? So we recommend what is better to use based on physical conditions, you can say, for solar modules. But for sure, there are specific or special technologies that used for some applications. We are not against it. We are not here to market anything, but we recommend actually the heavy duty ones, especially that when when we talk about Gaza situation, we are talking about temporary systems that will be installed for a few years, and then it should have a capability to be relocated to another place in the future. So this is why we recommend the heavy duty ones that is common used in the market. But we are not saying that you don't use any other thing that you may have in Gaza. So we highly recommend that you use whatever you receive, and we try to help you actually to be capable to use whatever you receive in Gaza.
Okay.
Yeah.
Could you just repeat the question, Naim, in English, or just give a...
No, he's talking about the flexible modules, like why it is not recommended to be used in Gaza. I just corrected the point. We are not recommending or not about any kind of modules. We just recommend to use whatever they receive there. And in general, we recommend the heavy duty ones because it's expected to be relocated in the future.
Yeah, I'll touch on that a little bit today, just briefly
Okay.
mention it. That's good though. Thanks, Naim. We had a good
Yeah.
refresher.
Yeah, go ahead, Caroline.
Yeah, and everyone can see my screen now, I hope. Let me just pull up my... Everyone can see the presentation screen.
Yes.
Yeah, okay, great. Yes, so welcome to PV System Installation and Safety, the fourth module for this course. My name's Carolyn. I'm originally a materials engineer. I have a materials engineering degree from Canada and then a master's degree in PV systems from Norway. So as I mentioned, this is the fourth module, and Naim just gave us a good refresher of what we've learned in the previous modules. A little bit about what we're going to talk about today. We'll go over some required tools for PV installations and a general overview of mechanical installation and for various mounting structures. Go over electrical installation and wiring and storage of materials when during installation. And then we'll go over some best practice and safety, construction safety, electrical safety. Some of it, I'm sure most of you know pretty well, just basic electrical safety. Some of it is a little bit specific to PV. So maybe have a bit of a refresher and some obvious things, and then some things that are very specific for when you're dealing with DC. And then we'll open up for questions. I'll try to keep my eyes on the clock. And please ask any questions. Just raise your hand. I've got my presenter slides, so maybe Naim or somebody can let me know when there's a question that pops up in the Teams chat. Yeah, so let's get started. So we went over in the previous slides what you should have in place to plan a PV system. So I just tried to list up some basic things that you should have before you actually start installation. Ideally, you would do a geological assessment and an environmental impact assessment. Both, it's typical to do an environmental impact assessment to make sure that you have the space and that you know what kind of ground, or a geological assessment to know that what kind of ground you're working with, depending on what kind of system you're installing. And permitting is also something to consider down the road. You need to know what equipment you're going to use, and ideally have done a yield assessment so that you have everything planned out so that you can work on your design specifications and know exactly what you're building, how many panels you're going to have in a string connected to which inverters. This is both for installation, but it's also a safety a safety thing to know what has been installed, and if you need to go back and do troubleshooting or during operation and maintenance, that you know exactly what's been installed, and drawings of the planned PV plant. And it's also recommended to do a health and safety risk assessment before you begin, especially with the team that's installing. Maybe not everybody has the same experience or expertise, and it's still important that everyone has a basic level of basic knowledge level of electrical safety and construction safety before they begin. So just an example of technical drawings that you might need: a single line diagram that shows the power distribution from the PV generator all the way to the subcomponents and the rate and size of those equipments. A lot of this you can get out of PVsyst, for example. Single line diagrams that show, for example, how many panels you have connected per MPPT, per inverter, any other subcomponents, protective devices, and systematic drawings as well of junction boxes, inverters, AC and DC distribution, meters, etc. You need a general arrangement and dimensioned layout that shows overall the layout of the PV plant, so that you can line everything up and install it correctly according to plan. And you need preferably drawings of the PV module support structures and how everything's going to be installed. For example, the tilt angle and the civil design, the azimuth of the system, of if it's going to be south-facing or exactly where it is in the land. So typically the way you start an installation is you install the mounting structure, and then you mount the PV panels. Then you would connect the PV modules together and then mount the BOS, which would be the string boxes, layout of any tubes or conduit for DC cables going to the inverter, and also from, for example, the inverter to the grid or other components. And then you would go on to on-site testing. For installing or for mounting the structures, there's not anything really specific you need. Just basic materials like a torque wrench, drill, maybe a metal saw if you need to cut some mounting supplies, a measuring tape. The easiest thing to do if you don't have heavy machinery is, and you're building smaller modules, is just stakes in the ground and string for marking out the layout, and shovels for digging, for example, trenches for cable laying and things like that. And then electrical tools, you'll need a multimeter, preferably an MC4 or DC connector crimping tools, which we'll talk about a little bit later, cable cutters and strippers, and cable strips. So we talked a little bit about the mounting structures. Stanislas talked about that in module 2. Obviously, flat roofs, if you're able to install on any rooftops, is a great way to save space. I saw in the comments someone was talking about the best way you can maximize the space. So, of course, building on existing buildings or future buildings is a huge benefit if they have the structural integrity to hold the weight of a PV plant. Inclined roofs are also another way, and they're relatively simple mounting structures where you have a row of sometimes I lose the English words when I'm describing things, but you have a row of your mounting plates, and then you just simply have a top construction and a bottom construction, and then you mount the module. And there's also a lot of systems that require zero tools that you can just kind of click in place. That could also be a benefit. And inclined roofs, it's pretty much just adding this this bracket and then a strip of metal to hold the panels in place. So they're relatively simple systems. We also talked about ground mounted a lot in session 2. So concrete foundations where you pour concrete into the ground to secure. Very stable, very durable, but again, high cost and long installation time. Driven piles, if the terrain allows for it, for fast installation. It's suitable for large-scale projects. Typically, you're using a hydraulic hammer to drive in these piles into the ground, and then ground screws for uneven terrain, which also requires specialized equipment. I think what the microgrid group has recommended is sort of a ballasted system, maybe not with concrete, but experience from other projects where you use material that you can easily get your hands on into sort of a cage system. I think we showed some pictures the last in session 2 and maybe the last session. And that's a good solution when you maybe don't have access to as much concrete as you need. And there's no ground penetration, so it's easier to remove. It often requires a significant weight. So high wind zones, you have to be a little bit careful and make sure that you're calculating enough ballast for a system like this, especially if you're going to raise it even higher. It really increases the wind lift. So that greatly increases the need for ballasting. I think also there are a lot of prefabricated sort of container solutions that can easily roll out of a container, for example, and they're great for quick implementation and mobility if you have to move a system quickly. Something like this would have no ground penetration. I'm not sure about the availability, and it may be a more costly solution. I know there's also solutions that are more raised, so something that you can easily roll out and click and maybe requires less tools and is more easily transportable, but is also raised like a typical ground-mounted system would be. So I would just say that there are many options out there. And it's important to find a solution that really works for you guys. And like you say, saving space is a huge thing. So perhaps an east-west configuration like this one you see here, instead of just a standard south-facing plant, would also be a benefit. So once you have your mounting structure finalized, you're most likely going to need to install the modules, unless you have this kind of container solution. So I want to talk a little bit about correct clamping of modules. So every producer goes through rigorous testing to determine the strength of the modules, both the force that they can withstand pressing down. This is obviously important in Norway. We look a lot at this because of the snow and the weight of the snow on the modules, but also for uplift. So when modules are tested for how much strength they can withstand, they're also tested in according to exactly where the modules are mounted. So most modules will have an acceptable range of where you can clamp them. It's typically for smaller scale modules. Typically the first quarter of module length, depending if you attach it horizontally or vertically. So this is just an example that I've taken from Longi and Trina, their solar data sheets, just as an example to show you. So for example, attaching clamping a module right in the middle here without any other support is not going to be stable and is going to result in problems down the line. So it's important that you really make sure that the modules are clamped where they're supposed to be clamped, or some modules on the frame, especially for larger scale plants, have holes for the bolts, and it will specify exactly where you should place these. So this is something to consider both in the planning phase and in the installation phase, so that you can dimension the mounting system so that it works with the modules that you have, ideally. Most modules can be installed horizontally or vertically. It's important when you're installing modules side by side that you have a small gap between them. This is for thermal expansion. So if you had the modules completely right next to each other with zero space, over time the frames will kind of expand and contract depending on the weather, and it could cause damage. So it's important to leave a small gap for thermal expansion that's specified in the installation manual, and use the proper torque that's specified when you're either bolting them or using the clamps. We talked a little bit about bifacial panels. So this last comment is more specifically for one-sided modules, where the backsheet, a lot of backsheets on modules aren't nearly as robust as the front, and it's a good idea to not allow them to come into contact with mounting materials to avoid damage on the back, so that you have a little gap from the frame where you're mounting, and any other screws or bolts. Kind of self-explanatory things, but yeah, a lot of this is outlined in whichever installation manual that you look at, but it's important to know what to look for because there's sometimes a lot of information in there. And then a little bit about a golden row inspection. If you're planning to build a large plant, it's common practice to have what we call a golden row inspection, where you design one row at the beginning and inspect it to make sure that it's according to the specifications, installation manuals, that everything's done properly, so that when a team that's installing a plant can then come back and look at that specific row if they're wondering, oh, how did we mount the panel, how did we run these cables or anything like that. Because as you can imagine, if you're building a larger scale plant, it's very easy for a couple mistakes to kind of get carried through the entire plant, and it can be extremely costly and time consuming to fix those mistakes afterwards. So again, kind of self-fix, or kind of a logical thing to do, but you'd be surprised how often people overlook this step. And I'd say it's pretty critical for if you're building like a 100 kilowatt peak rooftop system, and maybe a smaller or a large scale PV ground mounted. It's mistakes can quickly carry over. So this could be done, for example, for a mechanical inspection first, or an electrical inspection before the plant has been energized, just to make sure that all the cables are routed correctly and things like that. Any questions so far? I'll just take a quick look. Yeah, okay. No questions in the, let's see. Oh. Yes. So moving on to electrical installation.
Caroline, there was
Yeah.
a question there's a question in the chat now.
Okay. Excellent. Is there any simulation or automation softwares that could help us in understanding and designing? Could you be a bit more specific in you're talking about designing, for example, mounting structures with modules, more of the mechanical side? I can say if that's the question, I can say for rooftop, for example, there are typically the provider of the mounting structure typically does these wind calculations, for example, to determine how many mounting points you need or how much ballast you need on a rooftop. I would say for ground mounted, it's more that each company has a specific civil engineering spreadsheet or calculation that they do themselves. I'm not sure if Naim or Michelle, if he's still here, have any other experience with that of specific simulation or automation softwares that can help?
The main used one is the BVSYST that Michelle presented last week, and he ran a simulation with a team. And Zakaria, the question is generally question actually. If it is about BV side, it is BVSYST. But if it is about the structure, exactly as you said, Caroline, each structure manufacturer has its own software or simulation. Even most of them, they have free simulation online on their websites, where the user can put the main inputs about the project and get like a basic arrangement or idea or calculations about the project.
Yeah, but this is more, my experience is that it's more typically for rooftop installations, not larger scale ground mounted.
Yeah.
I can say that when you get to ground mounted, probably the most common is just to use like civil CAD products. And then there are a couple plugins you can use like VirtuCAD to kind of plan the spacing. And that would really help for technical drawings for ground mounted structures. But I don't know of any softwares that would then you need like a civil engineer then to calculate, for example, how much ballast you would need or something like that. Yeah. Yeah, but that's a really good question. We could maybe make a list of free software that we know of that can be utilized to give out at the end, if that's something people are interested in. So going over to the electrical installation. So as we mentioned before, you typically install modules in series. So each module will have a plus and a minus cable on the back in the junction box of the module. And how you connect the cables is also something that you can pre-plan in PVSYST. So exactly how the string design of everything. You want to try to avoid large loops. So just physically with the cables so that you don't have large loops for induction. And then all the cables you need are connected to each module except for what we call the home run cables. So the plus coming from the first module and the minus coming from the last module. If you keep the modules in a kind of standard installation, depending on where the junction box is, you shouldn't need to extend the cables on the back. Some modules have their junction box at the top, or they have like their plus and their minus at opposite ends. So it's important to take a look at that as well. So just general best practice is to make sure that you secure your loose cables with strips. That's really important for firstly making sure that nobody gets caught in the cables, or that it's not a hazard that a cable could be ripped out. And it's also important for example, drainage, that you don't have big hanging loops of cables. Ideally, you want UV resistant cabling or conduit. So black cables are best for UV resistance. But if you could get conduit or kind of something to cover over the cables, that would also be ideal for modules that are, or for cables that are not hidden behind panels, for example. It's important to use a proper bend radius. This is kind of general electrical best practice, and avoid resting on sharp edges. So I have two examples here. So typically there's a correct bend radius. You don't want to overbend the cables. You want to have proper routing. And obviously this is just a funny example I've taken. I hope this, I'm assuming that this wasn't energized yet, but this is an example of improper use of cables. You don't want to have kinks and curves that will damage your cables. And we have to remember that typically you're looking for a lifetime of 25 to 30 years for a PV system. Okay, so now I'm gonna talk about DC connectors or MC4 connectors. I would say that if there's one thing I want you to take away from this module, it's probably this topic, just because it is a common cause of fires in PV installations, mainly due to incorrect installation or mismatched connectors. In addition to the risk, it's also, as you can imagine, a humongous pain to fix after the fact, just because this is just an example. There are so many connection points. So, for example, this is just to illustrate how many connection points there are, which is probably why there is why it's so frequently linked to fires, because there's a lot of room for error. So this is one space, if you can, and if you have the proper tools and you can get your hands on the proper products, that you should have extra focus on this. So you can imagine that every time you're connecting a plus and a minus cable behind a module, that's an opportunity to correctly install the connectors so that you have proper connection and you can reduce risk of fire, and especially the home run cables. So this is what a typical MC4 connector looks like. The main supplier of these connectors is Staubli. I believe they're German, but there are also many other brands on the market. It's really important that you don't mismatch the connectors. So let's say you have Longi panels, and on the data sheet it says MC4 compatible. That doesn't necessarily mean that it's the same producer as the connectors you're using for these home run cables and also into the inverter potentially. So one easy thing that you can do is, for example, connect all your modules as you normally would, and then cut off the last connector and install a different connector that you'll be using for the home runs, so that you never have two mismatched male and female connectors. And then I don't think, I'm not going to play the video now because it's time consuming. There's ads and it's for a specific product that might not be relevant for you. But a majority of the cables, I just put a link to the video here if anybody wants to watch it on their own time, or look for another video, because it just kind of takes you through the steps of how you connect the MC4s. It's important to have the right tools, so you have the stripper to strip the cable, and torque wrenches. And basically what you do is you strip one end of the cable at the correct length, insert it into, depending on the type of cable, you insert it into like a metal clamp, and then insert that into the connector. It's the reason we use these connectors is so that we can ensure that we have proper contact, but also to keep out moisture and things like that. So I would highly recommend that you spend a little bit of extra time to make sure that all the installers have the proper instructions on how to do this part of the installation, and make sure that they have the knowledge or at least the proper training, and then follow the exact instructions from the supplier depending on the model you use. Are there any questions?
There's a question in the chat. 2 questions, I think.
Yeah, one of the what about blocking diodes that is built in the blocking diodes? I mean, are you talking about like I'm not sure if I'm familiar with that built into the MC4. I'm not sure if Naim or Michelle has more experience with that.
Usually MC4 connectors don't come with built-in blocking diodes. Blocking diodes comes as an additional items installed to protect modules from reverse current. But most of the recent modules technologies comes with built-in diodes inside the modules itself, like with each cells.
Yeah, and then one of the hardest problems I face is to disconnect the connectors, especially the old ones. I looked for the solution like using a plastic clamp, but it's not sufficient. Is there an easy way to do that? Yeah, I guess.
Comment.
Yeah.
Okay. Sorry, Caroline.
No, go ahead. Go ahead.
Yeah. So yeah, for this one, it is important, as Caroline mentioned in the tools part, there is a special tools for MC4 connectors to disconnect them. I agree, it is very difficult to do it manually. It needs some power, you can say, to open it. So this is why it is used actually, because when it is connected, that means the whole connection part is fully insulated. But it is recommended to have the proper tools always available at site at the connection and disconnection time.
Yeah, and I agree. It's also complicated because even if you have the same supplier, but you have a different model of connectors, you may require a slightly different tool to open the cap, or at least, yeah, the instructions will be slightly different. So, but the proper tools is the key here. Yeah. And then just general things to avoid. So let's say you're going to do an installation in kind of the rainier season. Try to keep all connectors away from moisture as best you can so that you don't get water inside the MC4 connectors. That's really important. And so take that into consideration if you can when you're installing the plant and what time you're doing it and looking at the weather and things like that. Another common thing we see is just that you've done everything correctly, but you have the connectors kind of installed in a low point in the mounting structure. So everything here looks really good. It's probably hopefully installed correctly with the right tools. It's clipped on, so it's not hanging loose. But what we see is that water can kind of trickle down and seep in. So the best thing would have actually been to mount this maybe at the top of the mounting structure if possible. So that's just something to keep in mind. Just have to get back to my... Yeah. And then just a general about the rest of balance of systems. All cabling should be properly supported. This is both a safety thing for the installation itself, but also public safety, that there aren't loose cables, animals, kids. So this is just an example of how using cable bridges properly mounted, and if it's possible, we try to have inverters depending on where the system is. This may be like a school or something where there's a lot of kids, so try to encase the inverters so that nobody can tamper with them or pull out the plugs. Avoid sharp edges. There's a lot of sharp edges on mounting structures, so it's easy to kind of forget this step. But if you have cables running over sharp edges for a long period of time, they will get damaged. Avoid UV exposure and moisture exposure. And in terms of mounting the inverters, always look at the manufacturer instructions. There's lots of different, for example, for rooftops, inverters can be mounted on an angle, just can be easier for space saving measures and just structural integrity, that you don't have to lift the inverter up. But for ground mounted, it may be easier to have an inverter per row or a combiner box per row if you're using larger inverters. And then a couple things about proper handling of modules. The modules, especially if you're using like 600 watt panels that I think have kind of been proposed by the microgrid team, they're heavy. So find a buddy and always use 2 people to carry the modules. Probably the biggest ones, you wouldn't be able to do it with one, but there are a lot of modules that are around 25 kilos that you could probably lift yourself, but if you're building an entire plant, it's not a good idea. And always follow the manufacturer's instructions when you're handling and relocating modules to avoid damage. So try to have, let's say you're placing the pallets try to keep them on even ground so that they're stable, so that they're not leaning on each other. I know that Naim talked, I think in the first module, about micro cracks and damage to the modules. And for example, storing modules upright like this, leaned over, it can easily create micro cracks and damage the modules or the frames or anything like that. So just try to be conscious of that when you're dispersing the modules during installation. Okay, so let's talk a little bit about safety. It's important to have the correct protective equipment. A lot of this is kind of self-explanatory, but it never hurts to go over it again. safety helmets, gloves, eye and face protection, ear protection if you're using heavy machinery, safety shoes if those are available, and then safety belts and lifelines and kind of harnesses like this. Protective clothing is also advised according to the weather condition, and safety vests, which isn't listed here, but being visible during installation, especially if you have heavy machinery. Main risk of the mechanical part of the installation is risk of falling. So it's obviously extremely relevant for rooftop installations, but also ground mounted. A lot of, if you have two modules in portrait, so right on vertically installed right on top of each other, you can get up to pretty high heights where you would maybe require at least a ladder or some type of safety protection mechanism. There's lots of different solutions, especially for roofs. These kind of perimeter roof edge protections, safety nets, harnesses, and lanyards. And for ground mounted, appropriately sized ladders. I've seen a lot of step ladders that aren't high enough, and then you're trying to climb up on the mounting structure, and that's when you can easily fall. So keep that in mind. I think in Norway, at least, it's anything over 4 meters is considered working in height. So you'll easily come up above 4 meters for larger ground-mounted systems as well. And also consider falling objects, such as obviously modules, but also tools and things like that. And then electrical safety, hand-to-hand electric shock, so touching plus and minus even before the plant is energized is a huge hazard. And also hand-to-feet electric shock in case of pole-grounded PV systems. Then you only need to touch one live part. You have to remember that PV modules generate DC power. So they deliver electricity when the modules are illuminated. And especially when the modules are connected in series or parallel, and parallel in string boxes or parallel switchboards or something like that, you can generate up to 1,000 or even 1,500 DC volts and several amps of current. So it's a lot different than AC in that manner. So that's something to consider. Each module has a voltage less than 50 DC volts. And the open circuit voltage, as I mentioned, is up to 1,000, sometimes up to 1,500. So always check the maximum open circuit voltage of the PV generator to make sure it doesn't exceed the maximum system voltage of the modules. And do not connect damaged modules if you can see visually that they're damaged. And again, try to avoid moisture and make sure that all the tools and everything are dry. Arc current is something very specific to PV that you have to consider because it's a DC arc current, which means that if you have a small gap in between the two currents, instead of just kind of flickering like it normally would in AC, if you get an arc current, it will actually build. So that's one reason why the MC4 connectors can lead to fires very quickly, and it can be very dangerous. So yeah, just keep that in mind. Carry out work only on de-energized solar modules. So if you're going to do something, make sure you have the proper control systems to de-energize the system before you work on it. And connect or insulate bare cable ends. So that's especially important during installation. when things aren't fully connected. Let's say you connect all the modules in series, but you're waiting to connect the home run cables to the inverter. Make sure all fastenings are tight and secure, and never disconnect the solar generator and inverter under load. Make sure that you're using the proper equipment also when you're installing electrical equipment. So the required PPEs, high voltage gloves, non-conductive footwear. And make sure you have try to fit the worksite with preventative and protective means. So appropriate barriers when you're installing, and proper signage, both for installers, but also for just the general public. It's important to label the AC and the DC side components for operation and maintenance later. And I would say it's best practice to always inform where a PV plant is and have a sign that says that even if the plant is disconnected, there's still voltage on the DC side as long as there's a light source. That's something that's often overlooked. Yeah, so let's see, this is maybe some of the, so all standard prevention measures when you're dealing with electricity should be adopted, which I'm sure many of you are well versed in. And always evaluate individual risks by a skilled professional. Yeah, keep in mind that PV modules and all DC wirings are electrically energized in the presence of light. That's really important. And always check for voltage with the proper instrumentation before working with wires to make sure that they're safe to handle. That's a general overview of what I had. I guess we're a little bit, went a little bit fast, so we have a lot of time for questions. I just want to remind everyone that NIME will be holding the operation and maintenance portion tomorrow, if I'm correct. So we're looking forward to seeing everyone for that. And let's open up to some questions. Any questions or comments, or even if there are other topics maybe that weren't covered that we could cover in a future module would be relevant to share if it's related to installation and safety.
Guys, any question, don't hesitate. Even if it is about language, you can ask in Arabic, no problem. But please don't hesitate.
Yeah. If MC4s are not available, what do you recommend in terms of safety? I know some of the people on our team here, maybe it was you, Naim, that mentioned that you've experienced installations without MC4s where you just cut the insulation, cap the wires, and connect them with electrical tape.
Yeah, there is a DC connectors. That one, I will not say that it is recommended, but
No.
it is something you can use just in case if it is impossible to get MC4 connectors. So the first option that is recommended always is the MC4 connectors because they are designed and manufactured for this purpose. But if you don't have them, you can go with DC connectors.
Mm-hmm.
Usually it comes with fuses, I think, the DC connectors.
Yeah.
Yeah.
And I just want to stress the fact that on the most data sheets, because MC4s, if I understand correctly, are specific to the Staubli producer, technically. but there are a lot of other producers that say they're MC4 compatible, and that's great for the modules, but it would be the absolute optimal thing to do is to use the exact producer and model of the MC4s or DCs together when you're connecting male and female. That's a really great and relevant question, though.
And something to mention about MC4 connectors, like during the presentation by Caroline, she mentioned that you need to keep them dry and protected even after you install them, but before you connect them. So it is important not to leave them to the open weather for dust or humidity or water. So the advice is to keep them covered until you connect them, but don't keep them open to dust or any other items to go in, because this will cause fire by time in future.
How about the types of MC4s that look like Y? Yeah, so the Y connectors. How many amps could that be rated? Yeah, Y connectors are fine to use if you want to connect two strings in parallel. I'm not exactly sure how many amps they're rated for. I guess that would be quite...
Yeah, this depends actually, Caroline. There is no standard answer for this.
Yeah. You'd have to look at the data sheet.
Yeah. It depends on the manufacturers, but in general, like for most of the recent inverters, actually, they all come with multiple strings and multiple MPPTs. I don't think there is a need with the current inverters to use Y MC4 connectors. You just connect direct to the inverters because the options are there. The Y connectors actually was there in the market where there was a gap in the inverters technologies, where there was a need for more strings and inverters had limited strings. So, but now I don't think it is required anymore, because you see even the single input inverters, I mean the small ones, comes with at least 2 or 3 strings. Rarely to have inverter with single string input.
And what software do you recommend for analyzing mechanical loads and verifying metal structures? So we talked about this a little bit in the beginning. It's tricky to... I would say a decent amount of suppliers for rooftop mounting structures have the software for mechanical loads. But for analyzing mechanical loads of ground mounted, I mean, I'm not exactly sure what is typical to be used. Just because that's more of a civil engineering side of it that I'm not directly involved in, but we could find out for sure what kind of software, if there is any, that's good for mechanical loads and verifying metal structures for PV plants. I'll write that down and see if we can share that. Unless, Naim, you know of anything?
No, actually, I agree with you. We check about any available or a free software for this, and then we can share it with the team.
Yes, and then a comment. Sometimes contractors are stingy and supply those Y-shaped cable to save cables. Yes, because then you save an extra home run cable. So that's true. So there is definitely a cost a cost benefit analysis on why you would do that. Why you would use the Y connectors.
But still not recommended. When you design a power plant to operate for 20 or 25 years, it's important to consider everything and to avoid such a minor savings. Like I can imagine, like for any project, you do this calculation or analysis, you consider any examples you want, and you will see the saving in DC cables out of overall project is less than maybe 0.5%, which is not that much important compared with considering proper installation and exact and proper run of cables for each string. So this is just an advice, especially that DC cables are not an expensive part of the project. We have Mahmoud, I think he raised hand.
Yeah.
Mahmoud.
Yes, thank you, Naeem. Thank you, Caroline. I would like us to ask if there is best practices in the installation phase lead to facilitating the maintenance later. This is one. The second point, the mountain of the MC4 just near or stick to the metallic components is lead later or to, for example, current leak, earth leakage, for example, especially during the high humidity environment.
Yeah, for the operation, I will be talking about this, Mahmoud, tomorrow, and I think we'll have some details about it because all are linked to each other. And about the other question about the MC4 connector, I think maybe you mean the example shown by Caroline in one of the slides, where it is not recommended to have the MC4 connector as the lowest point. You know, MC4 connectors come with their own built-in insulation system. There is an internal rubber and so on. So putting it in this way, that doesn't mean it will fail immediately. But again, when we talk about solar system, we talk about system that will operate for 20 to 25 years. That means by time, there is a high potential, you can say, by time you will, by having continuous water drop going in within the cable, like in this picture. So maybe it will not affect it at the first 2, 3 years, 4 years, but by time it may, in a way or another, enters inside the MC4 connector. That means it will fail and it may cause fire. So most of the precautions that we consider for solar and we recommend about them, that doesn't mean they will have immediate fail. So we talk about the project lifetime.
Exactly. How about a wood structure as an alternative solution to steel structure to mount PV module strings? I would not recommend it just because of the risk of fire. But I understand that, I mean, structurally, it's an okay solution. It's more of a fire risk that I would be concerned about there. So I would not recommend that. Even mounting inverters on a wooden structure, I would try to avoid.
Yeah. In addition to this, Caroline, also the wood doesn't have same details like aluminum or steel or the other kind of structure that we use. And you know, by weather and season changes, you have an extension and shrinking for the steel, aluminum, and so on. That is not there in wood. So by time, I know Oda that there is some existing examples in Gaza, and this is something. You know, it's like you can say a lot of miracles going on in Gaza, and we know that you guys need to use whatever you have. We are not against this, but when you talk about considering this as a permanent installation, it is not recommended because by time there will be more load applied on solar modules. Here we are talking about mechanical load. So solar modules frames are not designed to carry weight and load, but only the structure. So having wood by time will cause adding more load on the solar modules frame, and they may crack by time and you'll lose the solar modules. So it's important that you go with metallic structure.
Yeah, I totally agree. And then a really great comment from Saddam. One thing we also do before installation is measuring the short circuit current and open circuit voltage of one or several PV panels on site, as these parameters are location and condition dependent, and they tell you much more than the nameplate alone for the standard testing conditions. So yeah, in reality, you might have higher or lower temperatures, different irradiance levels, dust, humidity, aging, transport damage, and measuring tells you exactly how it behaves in that location. Totally agree, and that's a great point. And this is also something that you can do in PV-Syst as well, is because there you take into account temperature, wind, irradiance in that region, so that you have a better idea of exactly how the modules are going to behave.
Yeah. Also, we'll talk about this tomorrow as part also of O&M activities and practice at site after installation, about the tests that we have to do and so on.
Any other questions or comments before we close for today, and then meet up again tomorrow for operation and maintenance?
Maybe I can highlight some points in general, and just for a few minutes, and we get more questions if there are questions. Like, it's about the installation party. I know, like, for some projects, there are a consultant who does the design, and there is a contractor who does the installation, and so on. This is something important to know, like the barriers between these parties. So in general, for the installer, if the installer is not the one who did the design, if it is done by someone else, it is important always, as mentioned in the first or the beginning of your presentation, Caroline, that the installer should get the project documentation first. That includes the design, wiring diagrams, everything. So the first thing to be done is to analyze all of these the documentation for the project before doing anything. So analyze the drawings and do something called verify the design. So verifying the design, it is between brackets, like you are not redoing the design, but you just make sure that the considered in the design is applicable in the particular site. So usually some minor stuff happens, especially if the design is done by another party, not the one who's linked to the site directly. So this is important to practice to consider, and this saves a lot of time and cost if it is done at the first step of the project. So get the project document, review them, arrange site survey, verify the design, make sure that the design is applicable to this selected site. Another important practice to consider also for the drawings, if they are okay, you follow them, but if you need to do any changes during the installation, even if it is minor, for electrical systems, especially solar, there is nothing called minor, but if it is minor, it is important. So if you do any changes in the design, you have to update the drawings immediately. Like if it is about cable route, location of even single screw in the system, whenever or wherever you deviate from the original design, you have to update the drawings immediately, and this will be reflected in the as-built drawings later on. That is the responsibility of the installer to do. So don't ignore any changes and don't think that it is minor, because this might be a critical. This may save life in the future in case of accident. So the operator will depend on the as-built drawings that will be submitted by the contractor or by the installer. And when we talk about the safety, it is not just a term. Safety means it is a first mission for everyone whoever goes to site in the morning. His mission is to go back home safe for himself and also for his colleagues. So this is the target. So when we say this is a target, that means everything related to safety should be followed. No risks should be done at site for any reason, because there is nothing important than personal safety. Equipment can be replaced, anything else can be replaced. The last recommendation that I have here is to follow the manufacturer recommendation all the time. As an expertise, what we do actually and what we did in the last few sessions and the session even in tomorrow is that we are trying to share with you some practices based on an actual projects or experience that the team has, but most of them were based on manufacturer recommendations. So it is very important also when you plan for a project, you get the manuals for the equipment that you will install at site. Go through these manuals, read them carefully, and make full understanding about these products, the best practices, how to handle them, how to fix them, how to terminate the cables, how to store them. You will find everything in the manual. All information that you need, you will find them in the manual. The designers don't tell you all of these details. The softwares don't tell you this. If you size a system, you will get a selection of solar modules, you will get a selection of inverter, cable sizing, all of these important things, but it doesn't tell you about the details of each equipment and how to handle them. So it is important to go through the manufacturer manuals, installation manuals, before you start handling these equipment. So if this is done, the equipment will be safe, the team will be safe, the project will be installed correctly, and it will be like win-win for everyone, and all will be happy. So this is like a general points. Yeah, I just wanted to share.
Yeah, that's a really good point, Naim. And also, it's very important for the installation, but it's also very important for operation and maintenance in the future to have these documents available, because especially for products, the solar industry moves so fast. So, for example, panels that have been installed 7 years ago have completely different parameters than ones that are installed today. So it's actually really important to know exactly what products you're dealing with later down the road if you have problems.
I see there was one more question in the chat, Carolyn.
Yeah, would you recommend some brands that are reliable in delivering safety PPE? I don't know if I have any specific brands to recommend, unfortunately. And I guess brands may be different from what we're used to in Norway. I mean, I can say for sure that this isn't PPE though, but MC4 connectors and Staubli are kind of the golden standard in terms of that. But for PPE, I'm not actually sure.
I think civil defense has like a list of an approved or certified tools. I'm not sure about the civil defense in Gaza, but usually in each country and even each municipality, the civil defense has a list of recommended safety tools for everything, for electrical, mechanical, and other type of works and activities. I'm not sure. Maybe the team can advise, because I know we have some of audience who work in municipalities and other authorities. Maybe guys, you can advise for this point based on your knowledge. Anyone can advise? Anyone from any of the municipalities can advise?
نعيم.
Yeah, نعم تفضل.
I want to ask if there is a specific percent of damaged or originally damaged PV cells come from the manufacturers. I mean, or indirectly, I ask the question in another way. The site, when we started to mount in the PV modules, can we expect that one of them, for example, originally damaged or not functioning very well, and will later affect the whole system or the total system?
Yeah, this is very important question, Mahmoud. You asked at the last moment. Yes, this happens a lot. The reason for this is not about manufacturers. So we cannot say the manufacturers send or ship cracked or damaged modules. But, during shipment, you cannot assure that everything was followed as per manufacturer recommendation, loading, offloading, and so on, until it reaches the site. So it's still you can say possibility to have damage in the modules, even maybe at the last moment. If you saw in the picture shared by Caroline and the recommendation about how to carry the modules, maybe someone at site actually carries the module wrongly and he causes a crack. So the point or the summary is that yes, there is high possibility that you will have a cracked or minorly damaged modules installed. So the point for this one, we'll discuss about it tomorrow, but it is important to test and verify. There is different ways to do it. It starts from visual inspection. Some cracks you can see by eyes, you can see it, and then you just remove this module and don't consider it. Don't take any risk and say it seems okay and I will use. Sometimes you need to test it to check if it is okay or not. And also we'll talk about this, how to test the modules and make sure that they are okay. But again, it is not from manufacturers. It is about the shipment and usually logistics. So it is important that the full, you can say, series from the manufacturer until site to be followed as per manufacturer recommendation. So you get the operational modules.
Yeah, that's really great. And just to add on to that quickly, in terms of the producers, they typically provide a arc flash test sheet for sometimes all of the modules or a module per pallet to confirm that they had kind of been, that's kind of their last final quick test before they send them out for shipping. So that's also something you can try to look for, ask for from the supplier.
Any other
Okay.
question? Any question, any point, any idea for tomorrow's session? Because tomorrow will be the last session. So if there is anything that we didn't cover before and you like to hear more about it, so we try to add it for tomorrow's session.
Can we get a design model for a grid-tied solar energy project from scratch, including both electrical and mechanical design?
I think the microgrid team is working and
Yeah.
on a design for a system that will be shared with JITCO later on. Yeah, Zakaria, this is ongoing actually. In parallel of this training program, we have a design initiative that another team is working on it. So they will share it with the JITCO team once it is done, which is expected to happen soon.
And you hope to work on PVSys as well. That's great. Practice is key. To keep learning new things in PVSys and get a handle on it.
Yeah.
Awesome.
Any other question? Any point? Anything?
Thank you so much, Naim. Thank you so much, Caroline.
And Mariana.
And Mariana, of course. Always my respect.
As a last point in the chat, Naim, I guess that's for you. For tomorrow, if applicable, let's customize the presentation and content Gaza-wise. So I think Naim is very much trying to do so, but then there's also quite a lot that is general.
Yeah, we are doing our best. Oda, is it right like this? You call your name Oda. My family name is Odi. So I see Oda. Yeah, so we are trying actually in our program to cover it in two sides. One is to focus on the applicable standards and the ideal way to do the things. And the second one is to consider the Gaza situation and to try to use whatever you have or whatever you have access to, but to maintain the things safely. So we are trying to consider both because we hope that you will have the flexibility to choose the equipment and material you use in the coming future after they allow more material to access Gaza. So if this happens, you would need actually the general inputs that we considered. If you don't have this flexibility, you need to use whatever you receive, and also this part is covered in the sessions that we discussed about so far, and we'll try tomorrow to make it focused on Gaza in general. And we are expecting more collaboration from your side tomorrow because it will be the last session. Don't keep any question in mind, any clarification, anything you need to ask about. It is your chance, and we are happy to cover anything. We don't have a direct answer for it. We'll try to work on finding the correct and right answer and share it with you guys as soon as possible.
Thank you, Naim. I think that was a good final word. Thank you so much, Caroline, Naim, and thank you everyone for participating. And the link for tomorrow's session I put in the chat, also where you can find recordings of all the modules, and we'll see you tomorrow.
Thank you.
Thank you.
Thank you.
Thank you,
Bye.
guys. Assalamu alaikum.